So today's session is about like why ML is required for task categorization. So the use cases for ML for text categorizations that would be that categorizing customer support tickets, sorting emails, that would be for example spam versus not spam or by department, or auto labeling can be used. And text categorization is also called as text classification, and it is the task of assigning predefined labels or categories to text data based on its content. So the scenario over here would be like for customer support. For text example, that would be I forgot my password. That would fall under the category of technical. And the scenario for email filtering, that for that text example would be you have won a free iPhone, and the category that it would fall under would be spam. And for social media, the text example would be government policy needs reform. So the category for this text would be politics. And for news, as you can see, the text example is stock market hits all time high, and the category would be finance. Why we are not doing it manually? So why do you think that why it cannot be done manually? Any inputs on this? So, okay, I am not getting any answer. So, if you imagine a support center getting 10,000 messages per day, so the manual tagging would be that it would be very much like it is slow and it is inconsistent as well, because it depends upon the human judgment and it needs to be filtered manually. That means that a person needs to look at, like, for example, the filtration of mails only. So, like, if it is done manually, then a person needs to go through each and every mail, then they have to categorize it into which category that is falling under. So in that way they need to categorize it. But like if we use ML, then human labor is also reduced in this, and no inconsistency is also there, and it is not scalable as well for like manual tagging. So that is the reason like why we will not be doing it manually. And that's the primary reason because it is happening. So like enter machine learning. So ML based task text categorization automatically learns patterns in text and classifies it consistently and at scale. So what ML does is, like, it learns from the historical labeled examples. It finds patterns in word usage, structure, frequency, etc. And it also predicts labels for new unseen text. So the benefit for this would be, because it the speed of ML is one of the primary benefit, because it classifies thousands of texts in seconds, and consistency is also one of the prime factor for this, because no human bias or mood based labeling is done. And scalability is also there, because it easily handles growing data. And for this, customization is also there. We can train models for specific use case, that would be legal, medical, IT, etc. And real time use can be also embedded in apps, bots, and dashboards. So the step one for this would be that the data collection is there. Then step two is labeling. Then step three is train model, and step four is predict new text. So the real world companies using text classification would be Google, that is using email spam filters; Zendex, Freshdex, that uses auto tries support tickets; and Twitter is also there. It detects abusive content; and Amazon, it analyzes product reviews. So despite the name logistic regression, like, it is a classification of algorithm, not a regression algorithm. So it predicts the probability that an input belongs to a particular class. For example, whether a support ticket is technical, billing, or general. So let's say if we want to classify a sentence, the app crashes every time I open it. So we want the model to answer whether it is a technical issue, or, like, logistic regression assigns a probability to each class, and it selects the one with highest. So, like, how does it works? So text is converted to numeric, so it is converted using TF-IDF or bag of words, and each word becomes a number, that is weight. For example, reset password error becomes like this. So then we will apply the sigmoid function, and the formula for this function is over here. So basically, logistic regression is best when you want speed plus interpretability. So your data is linear or separable. That, for example, it would be a billing, word always indicate billing. So we use TF-IDF or bag of word, which works very well with it. So, and this, like, why use logistic regression? Because it is interpretable, it is easy to understand weights and coefficients, it is fast weight and lightweight, because it is good for small and medium sized data sets. And the probabilistic output, so output classes probabilities, not just hard labels. And it also perform well with bag of words and TF-IDF, and it is especially good with high dimensional sparse features. So there are some disadvantages of logistic regression as well. That is there because it assumes linear decision boundary, so it may underperform on complex patterns, and it is not very much ideal for highly non-linear data. So for this we can use random forest or SVM instead, and it is sensitive to irrelevant features, that is and for this we can use, instead of logistic regression, for this we can use feature selection, can be helpful in this regards. And it does not capture word order as well, because it and combined with engrams or embeddings. So now moving forward to random forest. So what is random forest? Random forest is an ensemble machine learning model that combines the prediction of multiple decision trees to improve accuracy and reduce overfitting. So example would be that understand what a decision tree does and learn how random forest improves upon it, and apply it to real text classification. Example that would be task categorization, and we can compare performance with logistic regression. So understand the decision trees. A decision tree splits the data based on feature values. Example is word frequencies or TF-IDF values. So is error in the message? Yes, then it is technical. No, then is invoice present? Yes, if it is billing. No, in general. So it is easy to interpret because it tends to overfit on training data. It memorizes it basically. So step two is that random forest is equal to forest of trees. So a random forest builds multiple decision trees on random subsets of data and features, and it aggregates the result using majority vote for classification. So the idea would be a group of weak learner trees can combine to form a strong learner. So why it works well with text? Because the text classification data is high and many words and features are present, and different trees can learn different word patterns as well, and trees won't all over same way. Trees won't all overfit the same way because model is more robust. So the expect for this would be that because it handles non-linearity, as I've mentioned in logistic regression, that logistic regression cannot handle non-linearity, and the handle feature interaction is also very poor for logistic regression. But whereas in random forest, it is excellent. Model interpretability for logistic regression, that is like high because of its coefficients, but for random forest because it is medium, because it is very much hard to explain hundreds of trees. So that is why it is medium, the model interpretability. So it also handles noise outliers and like more better than logistic regression. So this text example that can't access my dashboard. So the prediction category that it would fall under would be technical. So there are some text examples and there are some certain this categories, prediction categories. So basically this is used to categorize the text example into a category that it would be the most suitable to. So the change credit card on file. So for this, the prediction would be billing. So the random forest learns complex word interactions like if cancel appears with subscription, then it would fall under general. If card and payment appear together, then it would fall under billing. So the key takeaways for this is that random forest is powerful for linear data, is powerful for non-linear, that is high dimensional problems like text classification, and it reduces overfitting by using multiple trees, and it is slightly lower slower than logistic regression but more accurate, and it gives insights into feature importance, which matters the most, like which words matters the most, and the real world applications of task like text classification models would be help text routing. So the goal is to automatically assign support tickets or chat messages to the appropriate department like billing, technical support, customer, etc. So over here the categories are billing, technical support, customer service, etc. So the problem over here is that manually triaging thousands of supports messages is slow and inconsistent. So the machine learning solution for this would be that we will train a classifier based on historical tickets with label departments. So the example data is this, that I cannot reset my password, that would automatically fall into technical. The please update my payment info, that would fall under billing, and how do I cancel my subscription, that would fall under journal inquiry. So this is the example data that we'll be using to train the model. And then the workflow for this is that we need to collect historical tickets with assigned labels, then we need to pre-process, that is text cleaning, lemmatization, etc. Third step would be to vectorize using TF-IDF. Fourth step would be to train the model using the algorithm either random forest or logistic regression. Fifth step is to category for new incoming messages. Sixth step is to route ticket to corresponding team. So the other problem is over here is email sorting. So over here, we need the goal is to automatically sort incoming emails into folders like promotions, social, spam, updates, etc. And the problem over here is that user receives hundreds of emails daily and manual filtering is inefficient. So the email subject is that 50% off on your next order. So the category that it would fall under would be promotions. Friend request from John, that would fall under social category. Invoice for recent order, that would fall under updates. And congratulations, you have won a prize, that would certainly fall under spam. So these are the categories that email sorting would be consisting. And the workflow for this would be that we need to collect GitHub or Jira issue descriptions. Second step would be to pre-process the text, remove code snippets, clean up formatting. Third step would be to vectorize using bag of words or TF-IDF. Fourth step is the crucial step to train the model using random forest, because random forest handles noise and variation very well than logistic regression. So that's why we'll be using random forest. Fifth would be to predict tag for new issue or auto assign engineer or team. And the tools that would be used would be Zira REST API or GitHub issues, and the Python plus Skitlearn library could be used. And feature important
So
feature importance from RF can explain tagging logic. So the use case for help desk routing that is unable to update billing address. So the output category is billing. So the ML role is to it needs to route it to finance team. That's what it is predicting. And the email sorting is that congratulations, you have won a prize. And the output category is spam. And the ML role needs to filter it into a folder. Bug tracker tracking is that UI misalignment on iPhone screen. So that is a UI bug output category. So auto tag in bug tracker. So so over here we will be using logistic regression, and we are also going to use matplot library that is used to plot the graphs, and the sample data for this that has been used are listed below. And the labels that we'll be using would be billing, journal, technical, and yes, that would be. So, and TF vectorization is used over here, and TF ID vectorizer is also used. And as we are using logistic regression model, so we are using this. So we need to show top influential words per class. that we'll be doing. So as you can see, this is the classification report that is like, and the precision of all instances predicted as that class, like how many were correct, and recall is that out of all instances of that class, how many were correctly predicted. And F1 score is something like harmonic mean of precision recall that balances both. And the support is that actual number of samples for each class in test data. So as you can see this, that billing, the model failed completely for precision recall and FN score that all are zero. But for general, you can see that the perfect classification is there. And for technical recall is 1.0 because it caught the true instance, but precision is slow because it is likely misclassified as other technical as well. So the accuracy, that is like 2 out of 3 samples were correct, like classified correctly. So 0.67 is there. And macro average, that is unweighted mean overall classes because it treats all classes equally. So weighted average is that weighted by support. So larger classes influence more. And top words for class billing, because the word, the change, method, billing, and want. So these are the, as you can see, the top words and the weights they have calculated. So this is the data set. So as you can see that the top words for class billings are the change, method, billing, want. So the weights are placed in order. So these are the important words in the model that uses when identifying text as billing. And these weights suggest relevance or contribution towards classifying text into billing. So, but this model struggles with billings because despite having useful indicative words, but still not doing very well. This might be due to very small data set because only one example per class is there, and it is not enough for generalization, and it is imbalanced or overfitting. So please go through the code once. I will display the code. Eh, So the graph will also be there, but I don't think so that it is getting displayed while I'm sharing it. While I'm sharing the screen, it is not getting shared. So as I will share you the document, you can do it and check out. So okay, moving forward to other example, that would be help text routing. For this, we are using random classifier, forest classifier, and the sample data is listed above. And the departments that consist are technical billing journal. So the same departments that we used previously. So over here we'll be using random forest classifier, and the goal is to predict new incoming tickets. And the new tickets would consist that I cannot access my account dashboard or need help with payment for my last order and stuff. So support the billing has three true examples in the test set and technical has zero. And as you can see that for precision recall and F1 for all classes, that is zero because the model failed to correctly predict any classes. And the accuracy is zero because zero out of three samples were correctly classified. And my macro and weighted average is also across zero, also zero across all metrics. So as you can see that the billing has three true examples in the test set. So over here, what went wrong? Because zero predictions matched the true labels, and possibly the model corrected everything as a wrong class. So technical class has support zero because there were no true examples for technical in the test set. So F1 or recall score is not compatible, and billing, that is support, is equal to 3. None of the three examples were predicted correctly. So as you can see the ticket routing predictions, so these are the predictions for sample queries. I cannot access my account dashboard, so the predicted category is technical, that's correct only. And need help with payment for my last order, so this is also getting fall under technical, that is also correct. So third is like, how do I cancel the auto renewal? So this falls under general query. So as you can see this, that these outputs show the model is function, but it is making predictions, but they don't match the ground truth. So based on the classification report, so the true labels were all billing, but the model predicted otherwise, which matches the report, or the test labels are misaligned, or too few for meaningful matrix. So to improve this, we can check the data set balance. Like as I told, that imbalanced data sets can skew learning. And in our case, as you can see, that technical has zero test examples, which is not ideal for evaluation. And we can also increase the sample size. So for more examples per class during training and testing, it can stabilize metrics. Third is that we evaluate the confusion matrix, so it helps visualize which classes were misclassified as others. So and we can also manually inspect mislabeled examples, so see, and we can see that what the model is predicting and what we should predict actually, like what it should predict actually. And the feature improvement can also be done in this, because like we can add domain specific words, clean stop words, or use embeddings like BERT or for better performance. So these are the shortcoming of the example. So please go through the example. So this is the data set that has been used.
Ma'am, in the line number 44, I can see random underscore state equal to 42. So, and also in the 47 line, it is also used. So, what is random state?
So the random state parameter and random forest classifier, like it basically controls the randomness of certain operations, like making the results reproducible. So like introduces randomness in two main ways, by doing bootstrap sampling. So each decision tree is trained on a random subset with replacement of the training data, and the other one is that feature a subset. So at each split, only a random subset of features is considered. So what does this random state is equal to 42? So it sets the seeds for the random number generator. So this ensures that every time you run the code, the randomness, that is sampling and feature selections, behaves the same way, resulting in identical models and predictions. And why we are using 42? Because it is just commonly used arbitrary number. So
Okay, madam.
any integer will do for
Yeah,
this.
yeah. Understood, ma'am.
Okay. So okay, now we will proceed to email sorting. So over here we have used this sample data set, and the categories that we have used over here is promotion, social, updates. So over here, to predict on new emails needs to be done. So as you can see, this classification evaluation report. So over here, the precision recall and F1 score is 0 for all classes. So model did not correctly predict any of the true labels. And for support, promotion and social has one test sample each. And updates is 0 because that is no actual updates emails is in the test set. And as per accuracy and averages, everything is 0. So it indicates no correct predictions out of the two total test samples. So the model predicted three email texts. As you can see, this that biggest sale of the year on electronics, and that, and the prediction for this, it falls under updates. Second is that your friend John has liked your post. So this also, the predicted category that is falling under is that updates only. So likely it should be social actually, because your friend John has liked your post. So it should fall under social actually. And the predicted updates, like the biggest sales of the year on electronics, they should be under promotions, because they are promoting something. So the categories that we have listed above, but as you can see that it is predicted under updates. And for second one also, your friend John has liked your post, the predicted is updates, but it should be social. And the third one is that we have updated our terms of service, predicted updates. This one is rightly classified. And the observation for this is that model is predicting everything as updates only, because even though updates has zero support, no true examples in test set. So why it is happening? Because this is a sign of severe class imbalance or model overfitting in one class. So how can we fix it? By using class imbalance, like ensuring enough training and test samples for each case that is available. So, and we can use techniques like smart weights or undersampling could be also be there. Model diagnostics can be there, like for checking confusion matrix, evaluate predictions versus ground truth manually. And more data can be also there, adding more labeled samples across categories to improve learning. And the modeling techniques can also be like improved by using different classifier like svm bert or multinomial NB, and we can add more TF-IDF features or even pre-trained word embeddings to improve it. So please go through the data set. And this where the, like we need to predict it, like predict it predict it on this basis, but it failed as in the output. It is showing update for everything, so it is miserably failing. So these three scenarios in which we needed to predict. So for everything, the category is updates only, but for this, the biggest sale of the year needs to be held under promotions. And your friend John has liked your post should also come under social category. But yeah, we have updated our terms of service that can be like that is actually rightly classified, so that is there. But as you can see that this model is failing, so we need to create a balanced data set and more training data it's required to make it through. So guys, this is it for today. So in next session we'll be covering some other topics. So I think this all is giving a brief idea. Like you guys are working on a project, right?
Yes, ma'am. Yes, ma'am.
Okay. So these are the some these are some cases that needs to be taken in consideration while making. So
Ma'am,
please, yes,
yeah, from the data we can use in the program in Jupyter Notebook too.
yes, you can use.
Okay. After completing week one, week two, week three, week four, some task completed, so we have to build as a app, ma'am, website.
You can do that as well.
Okay, ma'am. Thank you.
Ma'am, is there any LMS portal available for this internship, like where we have to upload the project files, GitHub reports, etc.?
I am not sure about that exactly, but I will like I have raised this concern to the support team. They have not got back yet about this because somebody has asked about LMS before, right? So I have raised this, but yes, I will get back to you once they reach me out about this.
Okay, ma'am.
Okay. So that is it for today, guys. Thank you so much.
Thank you, ma'am.
Okay.
Ma'am.
I'll be
Thank you,
wrapping
ma'am.
up. Yeah.